Quick review of the wrapping functions for the quiz you guys have coming up here. So some definitions here to start. Coterminal angle, that would be two or more angles. All right, we got a freeze here. There we go. Two or more angles that share a coordinate. Okay, an example would be like 10 degrees and 307 degrees. Or sorry, 10 degrees and 370 degrees. Right? So initial ray, rotate 10 degrees. Okay, there's 10 degrees. And initial ray, if I rotate 360 and another 10, okay, they would both end and have a coterminal ray at the exact same spot. Quadrantal angle is an angle that falls on an axis. N axis, that could be the X or Y axis. Falls on N axis. Okay, either one. One full wrap is also called the period of the function. All right, so let's get into the wrap here. So a wrap of 0 we're given is 6, 0. Remember, we're always throwing the positive x-axis. A wrap of 1 will be up 1, that's 6, 1. Okay, I'm going to pause the video here real quick and label these so I don't need to go through wasting your time counting. So let's do a quick pause and I'll be back with you shortly. Okay, welcome back. So I got some labeling done here around our diagram. Notice I labeled my 3 at this point. I used Pythagorean theorem to figure out this was a length of 5. There's 8, this is 14, 16, there's 5 again by Pythagorean theorem. So on and so forth. I've identified my period to be 52. So I'm going to throw that in here a while, which means a wrap of 30 could also be a wrap of 82. It could also be, if I subtract 52, it could be a wrap of what, negative 22? Okay, so that's pretty easy there. Let's see where a wrap of 28 takes us. Here's 25, 26, 27, 28 is right there. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 9, negative 3. A wrap of 39 is right here, so that's negative 1, comma, 1, 2, 3, 4, 5, 6, negative 1, negative 6. A wrap of negative 16, well, I know these distances at least. That's 6, and that's also 6. That's 12, 13, 14, 15. 16 looks like we're there, which is negative 4, negative 6. A wrap of 44 is right here. So that's 1, 2, 3, 4, negative 6. 195, well, let's figure out the periods here. So 52 and 52 is 104, and 52 is 156. So 156 and another 52, 156 and another 52 is 208. That's 13 too many. 13 too many, so I'm going to go backwards. 13, well, here's backwards 12, and there would be backwards 13. So that would be 195, negative 1, negative 6. 3 plus a period, that's the same thing as 3. Boom. Right there, that's 6, 3. Domain, so that's my inputs. What can I put in? I can put anything in I want, all real numbers, right? So negative infinity to infinity, you can express that in either form you would like. The range, that's my outputs. So what comes out? Well, every time I've been getting a coordinate that comes out. And my coordinate are a set of x values and a set of y values. Okay, so my x values have been, what was this, negative 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, up to 6. And my y values have been from down here, which is negative 6, all the way up to 3, 6, 7, it looks like, if I can count. And again, you can write that in interval notation here if you'd like also. Symmetry, x-axis, no. Y-axis, no. Okay, so no symmetry there at all. Let's flip to the back and let's check out conversions. All right, so convert 320 degrees to either radians or degrees. Convert from either degrees to radians. This one is in degrees, so we'll convert it to radians. So I have pi radians, factor label here, and pi radians and 180 degrees are a fancy form of 1. Degrees cross out. I can cross the zeros out, and 32 over 18 reduces to 16 over 9, 16 pi over 9. 215, same deal. Pi radians, 180 degrees, degrees cross out. Now 5 goes into both these guys. 5 goes into 240 times, goes into 15 3 times, so it goes into 215 43 times. So that's 43 pi. 5 goes into 150 30 times, and it goes into 86 times. So it goes into 180 36 times. And they do not share anything in common there, so radians and radians conversion is done. 9 pi over 5, so now I'm in radians. So I want degrees in my numerator and radians in my denominator. Right, and the pi's cross out nicely here. 180 and 5 reduce. Oh, fortunately, we just did that. 180 and 5 reduced to 36. So I have 9 times 36. 9 times 30 is 270. And 9 times 6 is 54. 270 and 54 is 324 degrees. 5 pi over 6. Well, this one's an easy one. Pi, remember, is 180, but let's write it out factor label form. We have degrees over radians. Pi crosses out. Of course, the radians are crossing out. 180 over 6 is 30, and 30 times 5 is 150 degrees. There are our conversions. Reference angles. So I'm looking 0, 180. Well, this is 60 away from it. 60 degrees and 240 is down here, which is quadrant 3. 180 degrees is quadrantal. Okay, that does not have a reference angle. 300, well, this is 360 here as we go one full revolution, right? So we're 60 degrees away from that in the fourth quadrant, right? Quadrants are split up here. So here was 240, boom, 240. Here was 300. 855. So we have 360, we have 720, and then another 180 is 900. Well, 855 is 45 away from 900 in quadrant 2. Negative 240, well, negative 180 and 60, there's negative 240, which is 60 degrees away and also in quadrant 2. Not drawn to scale, FYI, right? 60 degrees is up here more than down there. Just getting a point of reference is all we need. Point of reference. All right, let's check out the radians now. So 5 pi over 4. Well, now I'm not looking 0 and 180. I'm looking at 0 and pi. Well, pi is the same as 4 pi over 4. In this case, 5 pi over 4 is just past it. So I'm pi over 4 away, and I'm in the third quadrant. 8 pi over 3, so now I'm thinking not of 4 pi over 4, but I'm thinking of 3 pi over 3. And 2 pi is 6 pi over 3. And 9 pi over 3. Well, 8 pi over 3 is pi over 3 away in quadrant 2. 13 pi over 6, I'm not going to write this one out this time, but I have 6 pi over 6, 12 pi over 6, 13 is right in here. Okay, so I'm pi over 6 away, and I'm in the first quadrant. Pi over 4 is quadrantal. That's the top of the circle. Oops, I'm sorry, pi over 4. I backtrack. I retract that last statement. Pi over 4 is, boom, right here. Okay, first quadrant, and it is its own reference angle. And 9 pi over 4 is coterminal, in fact, 2 pi over 4. So here's 4 pi over 4, 8 pi over 4, and 9 pi over 4 is right there in the first quadrant also. All right, so there you have it. Quick little review of your wrapping functions, and you guys should be ready for the quiz tomorrow. Remember, same quiz as this sheet, just different numbers. Have a good one.